Welcome to the ROQED Science Update Review. We are happy to announce that ROQED Science is now replenished with more 3D models, animations, functions and abilities to make learning fascinating than ever. First, there are more than 200 3D models were added. The models cover science subjects like biology, non-organic chemistry, physics and anatomy. Second, completely new mode called animation is developed so students and teachers can enjoy the app in a completely different way. In animation mode, information is presented in a more visual way, so users can visualize processes and elements that are hidden in a model view. It also helps teachers explain difficult topics in a simple way. Let's take a look at a couple of them. For example, an incandescent lamp. After opening the model, we can see an orange tab on the left upper corner. This is a name of regime of exploring the model. In the study mode, we can play with the model as in the sandbox, zoom in and out, dissect, rotate and move in space. We can study each element of the model by clicking on it. On the bottom the description of the element appears, and we can read more about it from there. In addition, if we press the half-human head, the machine-read voice start to read the relevant text. This is a new function that was not existing in earlier versions of the app. Voice reading function is especially useful when a teacher gives a lecture and lets the software do the explanation of the material. The full potential of the function opens when we proceed to the animation mode. To do that we need to click on the orange tab and select animation. The software will start the animated virtual tour on explaining relevant topic. The types of animations vary from the topic that is required to explain.
When current is supplied, the tungsten filament in the lamp becomes hot and starts to glow. The glow of a tungsten filament is a consequence of the fact that an electric current passes through a material of high resistance. In general, an incandescent lamp heats up because free electrons move along its metal filament and collide with stationary atoms on their way. The excited atoms begin to vibrate violently, increasing the temperature of the metal filament and causing it to glow. The wavelength of this glow coincides with the visible range of electromagnetic radiation. On average, the temperature of a tungsten filament reaches 3000 Kelvin. This is a very high temperature considering that the temperature on the surface of the sun is about 6000 Kelvin. Despite the high temperatures, the average service life of an incandescent lamp reaches 1000 hours. Earth's magnetic field, also known as the geomagnetic field, is the magnetic field that extends from the Earth's interior out into space, where it interacts with the solar wind, a stream of charged particles emanating from the sun. The sun's magnetic field and particles are called the solar wind. This wind is always pushing on the Earth's magnetic field, changing its shape. You change the shape of a soap bubble in a similar way when you blow on its surface. The geographic North Pole differs from the magnetic North Pole by about 500 kilometers. Plants are constantly in motion, but most plant movements occur slowly and are easily overlooked. Nevertheless, some plant movements occur very rapidly and are easily noticed, such as the leaf movements of the well-known Venus's flytrap and mimosa sensitive plant. Both living and dead plant tissues can display movement. In the picture, you can clearly see the lines of the magnetic field of permanent magnets of different shapes. So, the poles of the cylindrical and horseshoe-shaped magnets are located at different ends, and the lines themselves go from the north pole of the magnet to the south. As for the ring-shaped and disc-shaped magnets, their poles seem to be superimposed on each other and the magnetic field lines also go from the north magnetic pole. Two physical systems are in thermal equilibrium if there is no net flow of thermal energy between them. As different substances have different molecular structures, different strengths between atoms and different densities, it will take more energy to heat them up. The intercostal muscles are several muscle groups that run between the ribs and help shape and move the chest wall. The intercostal muscles are involved in the mechanical aspect of breathing. These muscles help expand and contract the chest, making breathing easier.
Welcome to the ROQED Physics tutorial lessons. ROQED Physics is a complete virtual experimental lab with more than 250 physics lab tools. The first virtual lab of its kind that contains real-world physics and obeys all nature laws. In order to install the app, first we need to go to the ROQED.com website and proceed to the Software, and then Physics Lab page. Then we need to scroll down until we see the link to download demo app. We will be directed to the demo app request page. Here we need to enter all required information. The link to download the ROQED Physics will be sent automatically to the email we enter. After we receive a link, now we need to download the app and install it. The installation process is simple and do not require special training. Just select the installation language and folder and click Next. The shortcut will be created in the desktop. Now the app is ready to be launched. To launch ROQED Physics, press the icon and press Enter button, or just double-click on the icon. After the launch, system might ask you to update the software. It is really up to you if to update or not. However, we recommend you update later time at your own convenience. This is authorization page. Please enter your email and set up a password to proceed with gaining access to the whole content of the app. After you created an account, you will be asked to enter the activation code. Please enter your activation code here if you already have one. After you enter an activation key, the app will start. If you do not have an activation key, please contact us by the email. Meanwhile, limited version of ROQED Physics can also be enjoyed in a demo sessions. That is all for now. In the next video tutorials, we will learn how to navigate inside the app and run simple experiments.
So good day, everyone. So we're here to discuss ROQED, and one of our products is actually an online product which teaches science to students at home and also physics. So the students at home can already do experiments through this product, and they only need this software and their laptop to be able to accomplish this. So first of all, what is ROQED? ROQED is a global education technology company that develops 3D science software and technology for schools. One of its products is the ROQED Physics Lab. So this product will enable to perform physics lab assignments online. It has also gone through the curriculum of physics courses, and its software covers up to 95% of the lab works. So as you can see here, in the background, this is a sample experiment which students can do at home. So now I will play a video of ROQED Physics Lab and how it works.
Complete virtual experimental lab to conduct all K-12 physics experiments. ROQED Physics. With more than 250 physics lab tools, any experiment is possible in a virtual lab. No need to spend money on hardware, no need to spend time on setup, no need to prepare the lab equipment, and no need to worry about mishaps. The first virtual lab of its kind that contains real-world physics and obeys all nature laws. It is all simple. Set up the lab, run the experiment, derive needed values, and estimate the error. Enjoy complete set of equipment to conduct all possible lab in virtual physics classroom. Try all virtual simulations that corresponds to the laws of nature. Feel the accurate and realistic 3D models. Create immersive experience into the virtual world. Run more than 40 pre-installed experiments with step-by-step instructions. ROQED Physics corresponds to all chapters of K-12. Physics, kinematics, dynamics, statics, hydrostatics and pressure, thermodynamics and molecular physics, electric circuits, electricity and magnetism, waves and optics. ROQED Physics, the lab for future Nobel Prize winners.
So the ROQED Physics Lab software includes kinetics, statics, and dynamics, molecular physics, and thermodynamics. It also has constant electric current, electricity, and magnetism, and optics. I will now show you a sample of how this physics lab looks like. Recording. Cute, Maya. So here, we have a sample experiment for Ohm's law. So Ohm's law states that the voltage or potential difference between 2 points is directly proportional to the current or electricity passing through the resistance, and directly proportional to the resistance of the circuit. The formula for Ohm's law is V is equal to IR. So we have V for voltage, I for current, R for resistance. And we also have 2 types of electricity, the alternating current and the direct current. So what we're using here is the direct current for ROQED. So as you can see here below, we have a sample experiment. So I have the ammeter connected to the key, which is connected to the power supply and the light bulb, which is lighting up. So through this experiment, you will be able to find out how to use the alternating current and the direct current. So again, so now the next experiment and product which we will discuss is rocket science. So first of all, what is rocket science? It is a computer program that provides the ability to simulate and conduct educational demonstrations for middle and high school students. It contains models and animations on biology, physics, geography, and chemistry. So as you can see below, here's a sample of one of its topics, which is volcanic eruptions. And on the right side, you will see the topics which it covers. Here are more samples. So on the left is the coronavirus, which we can all relate to. And on the right is an experiment of a fetal pig. Now I will play the rocket science video.
Studying science has never been so easy and exciting. No more bored and puzzled faces in class. No more inexplicable topics and materials for teachers. Introducing the first-of-its-kind app for any device that will turn an ordinary science lesson into a virtual 3-dimensional laboratory. The Rocket Science. Empower curiosity in the classroom. Interact with 3D objects by rotating, animating, and breaking down into parts. Create entertaining presentations and activities for students. Explore the K-12 education program with rocket science every day. Interact, engage, collaborate. Rocket science. Make learning fascinating like never before.
Hi everyone, so here we are again. So we have here the rocket science product, and one is the coronavirus. So what is good about this product is you can see that it can point out the parts of its topic, as you can see here. So it's like a 3D model which you can manipulate and disassemble. There are already labels and the colors of it will differentiate each item from the next. So you can also manipulate this experiment. So what's the benefits of ROQED? So first of all, there's individual learning pace for each student. So the student can be able to learn this software and the topics it covers on his or her own pace. The lack of equipment is being compensated. So the school and the student doesn't need to provide or purchase or use any laboratory experiments physically. And it is also now possible to perform an experiment that is challenging under a normal condition. So as said earlier, the student will be able to do these experiments at home through the use of this software. So they are not going to be able to be under the condition of any hazardous chemicals or things through a normal laboratory experiment, which they were previously doing before. And it is now possible to perform several experiments in a short time under different initial conditions. So that is ROQED for you. Thank you and have a good day, everyone.
Studying science has never been so easy and exciting. No more bored and puzzled faces in class. No more inexplicable topics and materials for teachers. Introducing the first-of-its-kind app for any device that will turn an ordinary science lesson into a virtual three-dimensional laboratory. The ROQED Science. Empower curiosity in the classroom. Interact with 3D objects by rotating, animating, and breaking down into parts. Create entertaining presentations and activities for students. Explore the K-12 education program with ROQED Science every day. Interact, engage, collaborate. ROQED Science. Make learning fascinating like never before.
Welcome to the ROQED Physics tutorial lessons. In this tutorial, we learn how to navigate in the app. First, please adjust the performance of the app by changing the graphics settings in the setting menu. ROQED Physics was optimized to work with integrated graphics of computers. However, if you feel that the program does not properly perform, it is advised to change the graphics settings to low value. When using ROQED Physics, students are able to submit their lab reports via internal services of the app. In order to do that, here we need to type the receiver's email address. Usually, it is a teacher's email or lab assistant's email. After we set up everything, we can go back to the main menu. Main menu of the app consists of 6 chapters. Each chapter contains pre-installed laboratories related to the chapter. Kinematics, dynamics and statics, thermodynamics and molecular physics, electric circuits, electricity and magnetism, waves and optics. Let's now consider a simple experiment. We go to kinematics section and start the lab about projectile motion. After lab starts, first thing we will see is a lab room with a blackboard and a table in center. On the blackboard, there is short introduction to the lab and its objectives along with the scheme of laboratory equipment that is need to be prepared for the experiment. On the left side of the screen, we can find step-by-step instructions, formulas and tables that a user need to fill in order to submit a report. As a teacher, we can use both internal tables and calculators of the app, or open a separate window for the Excel spreadsheet to gather and analyze the data. Now in order to conduct an experiment we need to set up required tools. The lab equipment can be found on the right side of the screen. Depending on the section that we are at, the app would give us different type of equipment for the experiment. For example, if we were in electrodynamics, then here we should have gotten voltmeter, power source, light bulb, etc. To study projectile motion, we need a ballistic pistol. Therefore, we just grab it by pressing the left button of the mouse and bring it to the edge of the table. The app will automatically recognize its place and turns green. It means we can place the pistol there. Now we can adjust the view by pressing the right button of the mouse, so it is more comfortable to work with the pistol. Next step would be to set up a launch angle. Let's set the angle to 45 degrees and then press play button or space on a keyboard. After a projectile launches and falls to the table, we can pause the simulation by pressing pause button or space on a keyboard. As we can see, there is data appeared on a screen. Here we can see the time of simulation, here we can see the time of flight of the projectile, and here we see the distance traveled by the projectile. This data can be then inserted to the table in the app, or in the Excel spreadsheet, or just written down on a paper. Let's gather the data in Excel and see how we can play with it. Just open a new Excel file and create 2 columns, angle and distance. For the sake of finding an error, we can add another 2 columns for the distance. Now enter the data obtained from the experiment. Let's redo the simulation by pressing the stop button and space again several times. As we can see now, ROQED Physics does indeed obeys to the laws of nature. The traveled distance varies with every run. This error was incorporated purposefully, so by the end of the lab students would be able to find the error propagation and uncertainty of their measured values. As we enter the measured values to the Excel file, we now can do some data analysis and derive other values like initial velocity and its components, maximum height of a flight, the work done by the spring and so on. Now go ahead and try it yourself, as the best way of learning is by practicing. That is all for now. In the next video tutorials, we will learn how to conduct a bit complex experiments.